Hi guys, Mr. R here, picking it up with the 8th grade class in chapter 13. So in chapter 12, we talked about the weather theory, kind of where the weather comes from and specifically things that we look for when we fly airplanes. But it's weather that also can apply to us in a lot of different situations. So it's a good thing to know where this weather comes from. Again, I get it. A lot of eye rolling and thinking, okay, weather, really? Once you start flying in it, you get a tremendous appreciation for weather, not just what it is, but what it can do to you. And in some cases, what it can do for you. Remember, weather is not always bad. Now we're going to talk about the weather services. So now, how do I get information that I can use to help me with my flight planning, my en route of my flight, and then my return home? How do I find information that can help me do this? Well, that's what we're going to talk about in this section. Next year in the high school class, the weather services that we go through will be a bit more in depth. Well, it'll be a lot more in depth. So what we'll concentrate on this chapter is the basics of where these weather services come from, and specifically what are METARs, what are TAFs, what are area forecasts, and where do we get this information? So that's what we'll begin with. When we look here at the aviation weather services, one of the things that we look at is we look at the differences here between forecasts and reports. And that's going to be a big thing. We know that weather forecasts are not always accurate. So it's a thing that we just have to know. Forecasts have gotten a lot better though, because back in the day, a 2-day weather forecast back when I was in high school is now as good as the 10-day weather forecasts that they're doing now. But that doesn't mean that weather can't change and other things can't happen, because, I mean, if you think about the complexity of air masses moving around the planet, it's kind of a crazy thing. You guys may have heard about, you know, if a butterfly flaps his wings in Peking, it rains in Paris. It's that kind of a thing that can happen. So just be aware. So when we look here, the first thing that we'll talk about are observations. Observations are somebody walking outside and looking around. Okay? That is an example of an observation. It can also be done now by an automated weather system on an airfield. Yes, we have robots out there on airfields that measure things like wind direction and velocity. They can measure precipitation. They can measure barometric readings. And all of this stuff is gathered electronically, and it can be disseminated almost immediately to pilots. So we have these types of observations are one of the things that we use to say, okay, what's happening now? Tell me what's happening now. Also, if we have some of the previous observations, we can start to develop an idea about a trend. Is the trend improving, or is the trend getting worse? And so those are things that as pilots we want to know about. So this is what we talk about when we get to routine here weather observations. This is what we call a METAR. It's a meteorologic routine weather report. That is what a METAR is. We also have AWOS and ASOS. These are going to be automated weather observing systems that we have on the airfield that gather this data, and it can broadcast it automatically on a particular frequency that you can get in the air if you're flying to an airfield that perhaps does not have a control tower. If the airport has a control tower, what you're going to be getting is the ATIS, A-T-I-S, Automated Terminal Information Service or System. That gives you information not just about the weather, but also about the airfield itself. So it gives you operational information in addition to just weather. So these are the things here. You guys have read this. You know what this is. ARTCC, this is going to be air route traffic control. These are going to be things here where you can also get weather en route if you need, but you can't count on that because they can help you when they have time, but some cases if they don't have time, then you have to be able to find weather information all by your lonesome. Upper air observations, we have surface observations, but then we also have these balloons that we launch, and these are going to be things where we send a balloon up in the air and they gather temperature, they gather barometric, they gather wind direction and speed data, also reports from pilots. Pilot reports, or PIREPs, is another great thing that we use. You can see the radio sonde is another thing that we talk about there. There's that. You guys can read this. Pilot reports. All of this, again, is just observations. Yep. Observations here, you guys have read this, everything here is good. We now have some of the snapshots that give us immediate information, which is radar. For instance, is that we can look at some of the radar stuff that we have for maps like NextRad radar, and we can find out what's happening here in various parts of the country just by looking at the radar. You know, of what's going on. So for instance, if we look here, here's an example of that XM weather. If you'll remember the previous class, you remember that big storm that we saw that was kind of there east-northeast of Dallas? Well, look where it is now. That cold front keeps pushing south, and it's pushing this storm right down here, knocking on the door of New Orleans. And this is one of the things that tomorrow morning is going to be bringing weather to the bayou. So these are going to be these products that give you this weather. But remember, when you look at something like this, it's not what's happening now. This is already history because it's normally 5 to 7 minutes before this information actually makes it to something like ForeFlight or one of these other stations. They're trying to get better at it to make it a bit more immediate, so that it doesn't have the longer, what we call latency periods associated with some of this information. But just know that when you're looking at something like this, in most cases, you're looking at history. But we can use that history because now we can go back and we can say, what is the movement of this cell and what is it that I might be able to expect? So if we look right here at this lower portion of this cell, which, by the way, if you'll remember what we looked at there with some of the cloud tops there before, we've got some cloud tops in here now that are pretty spectacular. So if we look here, we've got some counter rotation here in some of these cells. We have hail in some of these cells. We have a cloud top here at 45,300 feet. And you can see here this pinkish area right there. That is all kinds of rain built up in that cell right there. It also gives you a trend vector. So here is where they predict this cell moving in 20 minutes, 40 minutes, 60 minutes. They predict this portion of this cell to be over here in 1 hour. And so that's a 1 hour trend vector. You can see all of this lightning associated with this cell. And again, this is bad juju. When it gets that bright pink, that is some serious stuff happening right there. And I wish it would give me that cloud top information right there because normally those great big pink ones like that are pretty high. Here's another one down here in kind of the southeastern quadrant of this. This one right there, 53,700. So do you remember me telling you in the last class where it showed the picture of the tops of these at 40,000 feet? And I said, guys, those tops can be a lot taller than that. Well, here's one at 53,700 feet. So, and the spring hasn't even gotten cranking yet. So that's what's happening here with this. And this thunderstorm is headed right now with these trend vectors. You've got parts of this that's going to be heading east. Some of it's going to be heading south-southeast. So we will be looking for some weather in New Orleans here in a few hours. Just saying. So now, back to this. This is where you can get the radar. Radar can give you this, and again, like it says, it's updated every 4 to 6 minutes. It's really every 5 to 7, but they try to do better, and it gives you this information like we're looking at there right now. HIWAS, these are some of the things that you can get en route on VOR stations, satellites. Those are also some of the things in flight you can get through the flight service stations here. The flight service stations that you can get a hold of normally at 122.0 in the air, 122.1, 122.2. They can give you weather information. And another thing that we can also use when we're flying is in our cockpit. We also, if you guys remember the G1000, is that we also have the ability to get weather on our G1000. I'm trying to get over here to the MFD mode. We also have that ability to get the weather here on our G1000 here as well through XM or ADSB. So we can get this en route. Remember that what we're looking at there is history. So we would never use XM weather for any type of storm penetration strategy ever. The only time you would consider that is if you had onboard radar. If your aircraft was equipped with a radar system and you knew darn sure how to use it, that's the only time that you could look to maybe think, for instance, along this line here, let me bring this back up here for you, to say, okay, you know what I could do? I think I could probably fly right here between these two cells. I know, that would be a great idea. Well, that's kind of what we call a sucker hole. So that hole may not actually be there by the time you get there because it may have already closed in and you just don't know it. So we never, ever, ever want to do that. I'll get this out of the way here for now. So there's that. These are some of the other areas here that we can get information, some weather information. Also remember that some of this stuff is a bit dated, gentlemen, because we do things a little bit different now. However, it's still a good thing. On this, with weather briefings, I want you to write down the following. 1-800-WX brief. 1-800-WX brief. That is a phone number that we call to get our standard weather briefing and to file a flight plan if we so choose. Not everything has to be done on ForeFlight. You can if you want, but as long as this service is available, I will continue to use it. A couple of reasons for that is because when you're flying an airplane, they give you some help with your go, no-go decision. If they tell you, mountain obscuration, VFR flight not recommended. Let's say that you get that, and they tell you VFR flight is not recommended, but you go anyway. Then you have an accident. Let's say you survive. Now then, what do you think is going to happen with your insurance? Well, you left in conditions that you were warned not recommended. So what do you think your insurance company might think of your decision making? They may not pay the claim for your aircraft or Lord knows any other kind of property damage that you may have caused when you landed it wherever it is that you put it down. And then you're thinking, well, how would they know? Well, that phone call to 1-800-WX brief is recorded. They have a record of it. So they told you what it was, and you have a record of that. It also has a record of you filing that flight plan. So when you use the system properly and you do the right things for the right reasons, it can be there to help protect you. But don't look at this as being something to use to kind of skirt the system, okay? That is just folly. So don't do it. So the weather briefings are there, and this is the information that you get in a standard weather briefing. So I want you guys to read this. I'm not going to hold you responsible for this in the quiz, but you need to know what are the components of a standard weather briefing. And there are 10 of them that are listed there. That is a standard weather briefing. The abbreviated briefing is, let's say that you get that mountain obscuration via far flight not recommended, and you decide, I'll tell you what I'm going to do. I'm going to hold off an hour and delay my flight for an hour. Well, before you launch, you call them back. You give them your tail number. They've already recorded what it is that you're wanting, and you ask for an abbreviated briefing. Is there still mountain obscuration along the route? Nope. Satellites show that there's no cloud cover there at all. Smooth sailing. And they don't tell you it's okay to go, by the way. They just tell you, here's what it is. And the other reason that I like that system is because when I look at all of this weather and I try to connect the dots and I'm reading the tea leaves and I'm deciding, okay, how's the weather looking here? That service gives someone else at the other end of that phone that does this for a living that can kind of tell me if I'm looking at this correctly. And that's why I like it. In some cases, we see things the same way. In some cases, they'll see something that I don't, or I see something that they don't, and then you have a decision to make. They're not there to tell you if you can fly or can't fly. They'll say, we don't recommend this, and remember, the recording is on. So keep that in mind. Outlook briefing. You can also call to get an Outlook briefing if you're wanting to fly, in 6 hours or more away. Some cases you can do that a day ahead or the night before to get an Outlook briefing, just to kind of see how they're looking at what the next morning might look like for you. So now we're getting into the aviation weather reports. Remember, this is a report. It is an observation. Okay? These are observations. Here it is. These are METARs. And this is an example of what a METAR is. Here, let me read this for you here. This is for whatever airport this is, KGGG. And this is going to be on the 16th of the month at 1753 Zulu. It's an automated system. Winds 140 at 21, gusting to 26, 3/4 of a mile statute visibility. You have heavy thunderstorms with rain. You have mist. You have a broken ceiling at 800 feet, overcast at 1,200 feet with cumulonimbus bottoms. You've got a temperature of 18, dew point of 17. Your altimeter is 29.70. And the remarks here are pre-SFR. I'm not sure what that means. Pressure. Boy, I'm not sure what that means. So, but that's how you read a METAR. Got it? Reading METARs is kind of the secret handshake of flying. It's an arcane method of disseminating a weather observation, but we still use them. And the FAA still tests you on whether or not you can decipher them. So, there's an easier way to do it. Let's take a look at how ForeFlight does it. So if we look at this, and I look at Aspen, and I want to say, okay, what's my weather like in Aspen? Well, here we go. Let me open this up here. So if you look at this here in the green, here's the weather in Aspen. At Aspen, on the 7th of the month, at 053 Zulu, winds 180 at 5, 10 statute miles visibility, clouds scattered at 2,000, broken at 3,500, that's AGL by the way. There's an overcast layer at 5,000 feet, temperature is 6, dew point is 3, altimeter is 29.90. Remarks AO2 is going to be a precipitation discriminator. And they have rain ending at 25 after the hour. Sea level pressure is 1006.6. There has been some pressure, and then it also gives the temperature as 6.1 degrees Celsius, and the dew point is 3.3 degrees Celsius. So that is all in this green writing that you see here. Below it, it gives you the actual English portion of it. And that's the part that you guys can actually read. Oh, I thought I was on the wrong thing. Dadgummit, guys, I'm sorry. So if you look at the green, and I can't, the ForeFlight screen won't let me blow this up anymore, and I can't do it here. It's not going to let me. But that green piece is a METAR, but down below it is a plain English translation of it. And you're thinking, why in heaven's name can't we just use the actual plain English translation of a METAR? Good question. But we still need to know what they are. So how do we learn METARs? Well, when we look over here, the first thing that you'll know is that the METAR information, each one of these segments is given to you the same way every time. So there is a pattern to how they give you this information. One of the things that you will have to memorize next year is going to be the pattern at which this information is given you, not just the information, but the pattern itself. What goes where? First thing is going to be the date and the time. Next thing is going to be the wind. Then we have visibility. Then we have some of the things that are actually occurring on the field right now. Then we have sky conditions here. Okay, then we have our temperature and dew point. We have our altimeter setting, and then we have any remarks that show up after that. So that's the order that this stuff is given to you. And this information right here tells you how to read one. Okay, I want to get down here to see what the remark is. I didn't see what this is for. They don't even tell you what it's for. Losers. Okay, now take a look here. This is something that I want you to pause the video and I want you to write this down. Pause the video and I want you guys to record this. So here we go. You have a qualifier and you have weather phenomena. Okay, so here's the qualifier. This tells you intensity here. So you have a minus sign, it means light. Moderate, there's nothing. A plus sign is heavy. VC stands for in the vicinity. Okay? Then you have a descriptor here, number 2, of these particular qualifiers. So MI is shallow, BC is patches, DR is low drifting, BL is blowing, SH is showers, TS is thunderstorms, FZ is freezing, and then you have PR for partial. I want you guys to draw this. Get this out because you're going to be using this to help decipher some of these METARs. So go ahead and pause this right now and record this. All right, welcome back. So now that you've got that done, that'll help you as you start looking at some of these METARs. Well, you'll notice right now that we stopped looking at METARs. We went right to PIREPs. Well, that's no fun. So let's go over here and let's look at how we might be able to perhaps look at some METARs and have a little fun here, shall we? So now, write this down. aviationweather.gov. aviationweather.gov/METAR. METAR. aviationweather.gov/METAR. Now, let's have a little fun. If we scroll down here to the bottom part of this page to request some METAR data, we can start plugging in some IDs. So let's do that. And I have plugged in some here previously, and let's look at what those might be. Okay? So now, this is what I'm going to do, and I plugged those airports in, the ICAO identifiers. Let's see what we got. So here we go. And let me get this over here. Hang on, I need to get this right there. Okay. Now, oh, yeah, it's going to do that to me. Okay. So now, let's look at this. So here we are. There's Aspen. Okay? Here is the date and the time in Zulu time. Zulu time right now, we are 6 hours behind Greenwich Mean Time, and we use a 24-hour clock. So that is going to be at 00:53 Zulu. So 53 minutes after the hour, that's when this report was done. Next thing it gives us is wind. Winds from 180 at 5 knots. So the winds are out of the south at 5. Next we get visibility. 10 statute miles visibility. Statute miles, remember, these are things that happen on the ground, right? Because in the air we use nautical miles. So why do we have a statute mile here for visibility? Well, the visibility is designed to see if you're on the ground, how far can you see? Well, in this case, you can see at least 10 miles. So that'll get you in and out of most any airport, right? So that's kind of what you want to see. You want to be able to see 10 statute miles on the ground. Then we start here, once we get the visibility, then we get into sky conditions. In this case, we have a scattered layer at 2,000 feet. We have a broken layer at 3,500 feet. Clear, few, and scattered are not a ceiling. Clear, few, scattered are not a ceiling. Broken and overcast are a ceiling. Okay, so that's a ceiling when it comes to VFR flight. We can't fly through that VFR. We've got to be somewhere on an IFR flight plan to penetrate that. Okay, so overcast at 5,000 feet, and remember, these reports here of these sky conditions are all reported AGL, above ground level. So it's not MSL, this is AGL, all of these. Okay? So, scattered, that's not a ceiling. You could fly around those clouds and stay VFR. But broken and overcast, you're not getting through there without penetrating a cloud. So, that's a ceiling as far as VFR flight is concerned, or even IFR flight. Okay? Then we get over here, we get the temperature and the dew point. Remember, the temperature and the dew point, when they're within 3 degrees of one another, we may expect reduced visibility. Well, guess what? If we look over here now, and we can kind of see what's our visibility, well, it's somewhat restricted as we look up. Well, we should expect that because we see that the spread between the temperature and the dew point is pretty close. All right? Then you have your altimeter setting, 29.92. Then you have your remarks. AO2 is an on-ground precipitation discriminator. There is AO1 and AO2. AO1 will tell you that you're getting precipitation, but it won't tell you what kind of precipitation. AO2 will tell you the difference between a mist and rain, or sleet and snow. Okay, so that's a precipitation discriminator. This means that the rain ended at 25 minutes after the hour. Sea level pressure is going to be 1006.6, and then your temperature is here at 6.1 degrees Celsius, and your dew point is 3.3 degrees Celsius. Okay? So you have Aspen here, there's Eagle, there's Denver, there's New Orleans, and there's Honolulu. Okay? So you can look at those, and you can go to this site and plug in some of your favorite cities and some of the favorite places that you want to fly or have flown. And you can go to this site and you can practice on the METARs. Well, you're thinking, all right, how do I do that? Oh, did I just knock that? Oh, shoot, I didn't mean to do that. Hang on here, let me reload that. That was kind of a bummer. Aviationweather.gov. Fortunately, I do this quite a bit. So why isn't that working? There we go. Okay, so now I can go down here and I want to go to METARs, click METARs. I want to go down here, open this up, METAR report, and I'm going to plug in those ones that I had in there before. Remember, you have to separate them by a space. Don't use commas, don't use any other dashes or anything, just separate them by a space. So for instance, with that, you'd have KASE space, KEGE space, KGJT space, whatever it is that you want to use. Now, you can see here that I chose raw. How about if I click decoded? What will happen then? Let's look. And, can't reach this page. Well, it worked in rehearsal. Let's find out what has happened here to our internet. I don't know what has just happened here, guys. Aviationweather.gov, METARs. Let's plug this in again. Isn't this fun? There's that. I want the decoded. Get the METAR decoded. Now look and see what we've got. So now what you can do here is this. Now you can pull these up and you can get the METAR, the raw METAR data from the airport, and you can compare it to the actual real English given to you here below it. And so you can learn how to read these METARs by using this aviationweather.gov, click on METARs, and you can do the decoded method and look at the raw, which is going to be in the gray, and then the decoding down below, okay? So you can learn how to do these. So what's going to happen is I'm going to give you guys an assignment, okay? But I can't give it to you right now because it's going to change before. So this will have to be done in class, and I will have Mrs. Benton do this for you. And what I will do is I am going to give you a list of several airports, probably 10, and I'm going to do a raw METAR and then a raw METAR request. So I'll have the raw METARs for 10 airports. Then you're going to, on paper, decipher what all of those things mean. All right? So that'll be on your next quiz, is METARs. So right now, I want you guys to kind of pause this. Let's pull up some of these METARs there in the computer, there in the classroom, aviationweather.gov. Let's pull up 10 of your favorite airports, plug in the 4-letter ICAOs, and start working on how to decode these METARs, okay? You may need to go back and replay this portion of this video here where I showed you how to record them and showed you what each little part of that meant, okay? So that you know what those things are. So just keep that in mind, all right? So there you go. Have some fun with that. The next class, on part 2 of this, we're going to talk about TAFs, Terminal Aerodrome Forecasts. They are going to be very similar to METARs, but instead of an observation, it's going to be a forecast, a prognostication, or a guess. That's what we're going to look at, okay? So there's that. Guys, have some fun with this, and I will see you here on the next class. Guys, have a great day.